In this video, we'll learn about another important building block that we can use for constructing digital circuits, specifically the decoder. To introduce the idea of a decoder, let's look at a specific application. Let's say I had 4 light bulbs that I wanted to control. That I'd like to turn on one at a time. That means I'm going to need at least 2 bits of input to control which of the 4 light bulbs turns on. And I have 1 output for each of the light bulbs. This is a standard decoder. When the inputs A0 and A1 are both 0, light bulb 0 will turn on. I have a 1 on output 0, and the other 3 outputs are all 0. If I instead put 2 or 1, 0 on my input, the line corresponding to 2 will have a 1, and the other 3 lines will have zeros, turning on the second light bulb. So for a standard decoder, the inputs are really an address of the output line that is 1, and then the rest of the output lines are 0. So for a standard decoder, exactly 1 output line is activated, and the input lines specify the address of which output is to be activated. So how many inputs do we need in order to activate one of up to k outputs? Well, we're going to need at least log base 2 k of inputs, or specifically the ceiling of log k. Now for standard decoders, we usually also put the number of inputs and outputs in the name, so we would call this a 2:4, or call this a 2 to 4 decoder. So standard decoders, if they have n inputs, will have 2 to the n outputs, and we would call that an n to 2 to the n decoder. We can also think of decoders in a more general sense of taking some bits of input and producing a unique output for each input, but having less than 2 to the n outputs. And these are also called a generic or general decoder. But for the most part, when you hear someone talking about a decoder with digital logic, they're most likely referring to a standard decoder. So let's look at how we implement a decoder, what's inside of the decoder. The truth table looks like this. So because each output is 1 for a unique input combination, for each output, I'll essentially have one AND gate. So D0 is a 1 when A0 and A1 are both zeros. And D1 is a 1 when A0 is a 1. And so this is our standard decoder implementation. Now if we wanted the capability to deactivate or set to 0 all the output lines, we'll need to add an additional input signal in many digital modules, and many modules include what's called an enable signal, or E for short, where when enable is 0, all the D outputs are zeros, and if E is 1, I get the normal decoder operation. And it's really easy to add the enable to the circuit, because now all I have to do is tie this enable signal as the third input to each of these AND gates. So another way to look at a standard decoder, given each of the outputs is a single AND gate with a unique combination of the inputs, or in other words, a minterm, a decoder is also sort of like a minterm generator. So any n-variable function can be implemented using only an n2n decoder and a single OR or NOR gate. So for example, let's say that I wanted to implement a full adder using a 3 to 8 decoder, because a full adder has 3 inputs, A, B, and C in, and generates 2 outputs, the sum and the carry out. So with a 3 to 8 decoder, now note, it's important that I label the inputs and the outputs so I know which bits are significant and the corresponding lines to the inputs. So for my full adder, I'm just going to tie my 3 inputs into the decoder. Inputs. And now each of these outputs corresponds to one of the minterms with these three variables, or one of these combinations. So 0, 0, 0 corresponds to when I have A naught, B naught, C naught. 7 corresponds to when I have 1, 1, 1 on each of these, so A, B, C. 1 corresponds to A naught, B naught, C, and so forth. So the sum is the OR of minterms 1, 2, 4, and 7. Those are the 4 input cases where I have a sum equal to 1. For the carryout, well, I have a carryout when the input is 0, 1, 1, or 1, 0, 1, or 1, 1, 0, or 1, 1, 1. So to recap, the decoder is a useful building block in digital circuits. A standard decoder has n inputs and 2 to the n outputs. Make sure you label both the inputs and the outputs so it's clear which outputs are activated for the particular input combinations. And we usually draw a decoder with just a square box or a rectangular box.